Translations. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point called the center of the dilation. And it has a scale factor, which we usually call K. So if you ever see K equals, that's what you're going to multiply by. And it's either going to be a whole number or a fraction. And that's what's going to make it bigger or smaller. And this is like the basis of, what you see in your animation, like your movies, your cartoons. So this is where the basis of all that comes from. So an original image may be labeled. You've got your coordinates. A is 1, 2, B is 0, 5, C is 3, 1. This is going to be called your pre-image. Okay, that's the pre-image. It's called the image after the reduction or the enlargement, and it will be labeled, and this is called A prime 2, 4, B prime 0, 10, C prime 6, 2. So you can see that everything was doubled. So in this case, your scale factor or your K would have been 2 because everything would have been multiplied by 2. All right, so for example 1, we're going to enlarge or reduce each set of points by the given scale factor. And we're going to use our points. We're going to use these set of points, -2, 0, 3, 4, and 1, -6. And those, these right here, those should not be there. That was a typo, okay? Because those should only be in the resulting image, the final image. Okay, so for the first one, we're going to multiply everything by 2. So 2 times -2 is going to give us -4. And then, of course, 0 is going to stay 0. Then we'll get 6, 8, and 2, -12. So then the second one, we're going to multiply by 1/3. Okay, so you can just type in 1/3 in your calculator and multiply it by -2. So you can do a decimal here. You can do it as a fraction. We'll get -0.67. And then, of course, that's going to stay 0. This one's going to be 1. We get 1.33. And then 1/3 times 1 is 0.33. And 1/3 times -6 is -2. Okay. So then finding the scale factor of the dilation and then tell whether it's a dilation or reduction. So remember, like what we just looked at, when you look for the P prime, and I know it's a little fuzzy here, but right here where you see the P prime, that is the image, okay? That's the final image. So here is P, this is P prime. So this is the pre-image, this is the image. So the image, this is the final, okay? That's the resulting image, okay? So that is the end, okay? So when you do the scale factor, you put whatever it ends up being, you put that number on top, okay? So the bigger one, the big number, so the paperclip, the big paperclip has a number of 12. So we put 12 on top. The small number is 8. So our scale factor is 12 over 8. Now on all of these, I want you to reduce. So 12 over 8 is going to reduce, let's see, 4 goes into 12 3 times, 4 goes into 8 2 times. So our scale factor is 3 over 2. And of course, it got bigger, so we would say that this was an enlargement. Okay? Now, also, when you are doing these and you're typing these in Canvas, an enlargement, this number right here, if you put down enlargement, this number should be bigger than 1. So anytime you put down enlargement, this number, your scale factor, your K, should be bigger than 1. If you write down reduction, your number should be smaller than 1, okay? So whenever you write down reduction, make sure you don't write down reduction and have a number bigger than 1 or vice versa. So keep that in mind as you're doing these. Okay, so for our second one, this one is P prime. You can barely see that little, the little mark there, and then here's P. So this one is the final image, okay? So the 18 goes with the smaller numbers. The 18 goes on top. The 30 goes on the bottom. So we reduce this fraction. So let's see. 6 will go into 18 3 times. 6 will go into 30 5 times. So there's our scale factor. And of course this was smaller, so this would be a reduction. Okay. Now, this one, okay, so obviously the bigger one, so you can see like you've got your A here and you've got your prime, we've got the coordinates. So the bigger one, we can go ahead and write down enlargement if you want to, because it got bigger. Okay, now there's a couple of different ways that you can do this. There's 2 different ways. One way is you can look at your coordinates. So if we look at the coordinates for A, point A, we've got 2, 1. And then for this A, we've got, we have 6, 3. And we can compare those. So we would put, we could just look at the X values, okay? So if we've got 6, because remember that's the one that goes on top, 6 over 2, and that reduces to 3. That's the scale factor of 3. That's one way to do it, is just compare coordinates. The other way of doing it is we could just count the bottom, since it goes straight across. Now you want to do something that goes straight across, like either straight horizontally or vertically. You wouldn't want to count, like for example, you wouldn't want to count like the side here, because that's hard to count the coordinates. All right, so if we just look at the bottom here, we could count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if we do this one, 1, 2, 3. And that also gives us a 3. So you could also do it that way. So you could either look at coordinates, or you could look at a base, or you could look at a height of your shape. Okay, on D, for D, we see that the smaller shape, we find the prime right there. So we see that this one is a reduction. Okay, so that means our smaller number goes on top. The coordinates of S, we see that the coordinates of S are -2, -2. And the coordinates of this S are, let's see, 1, 2, 3, 4, -4, and 1, 2, 3, 4, -4. Okay, so we've got -2 over -4, which is going to reduce to 1/2. So our scale factor is 1/2. Now, when it does give us coordinates only, then what you want to do is you can just compare 2 points. You don't have to look at all of your points, okay? Now, obviously, this right here is our resulting image. So that's the one that goes on top. So we have 4 on top, 2 on the bottom. So you remember, you just look at just the X. You can either look at just the X or just the Y. You don't have to look at both. So 4 over 2 reduces to 2. And since you can't see a picture, you kind of have to rely on, is it bigger than 1 or is it less than 1? Since this is bigger than 1, this means it's an enlargement. Okay? So for this one, pay attention, because this time it gave us this one first. So this was the resulting image. Okay, so if we look at this number, we've got the -1 on top, -3 on the bottom. And so that just reduces to 1/3. That's our scale factor. Since it's less than 1, we would say it is a reduction. And let's see, oh, I skipped one. Let me go back to this one over here. So if we look at this one, we see that the green image is the resulting image. So if I look at my coordinates, I'm just going to do my coordinates for B here. If I do my coordinates for B are 2, 3. And it looks like my coordinates for the other B are 1, 2. So if I compare these coordinates, I put 2 on top, 1 on the bottom. So 2 is my scale factor, and it was an enlargement. Okay. All right, so now we talk about vectors. A vector contains a horizontal and vertical components denoting which direction a point has moved in a translation. The vector from the translation to point P to Q is 5, 3. So this part right here is just showing the direction that it's going. It's not actually part of the shape. It's just showing it's going 5 units right, 3 units up. So this part right here is showing you the horizontal direction, and this part right here is showing you the vertical direction. So this is what you're going to do to X, and the 3 it would be what you do to Y. Okay? And so all you're going to do for these points, the 5, being this a positive, you add 5 to your X's, and being the 1 is negative, you subtract 1 from all of your Y's, okay? So all you do, like for A, point A, and I'm going to write this out, you're going to do 0 plus 5, and we have 3 minus 1. And for point B, I'm going to do 2 plus 5, and I'm going to do 4 minus 1. And for point C, I'm going to do 1 plus 5, and I'll do 0 minus 1. And so when I simplify that, I will have 5, 2. For point B, I will have 7, 3. And for point C, I will have 6, negative 1. Okay? So you're not going to do these numbers to both, remember? So the first number is just to X, the second number is just to Y. Now, these can be written 2 different ways. We can write it like that. It can also be written a little more clear. I like it written like this because this specifically has X plus 3 and Y minus 1. So for this one, for A, I have negative 1 plus 3, and I have the 2 minus 1. For my B, I have negative 1 plus 3 and 5 minus 1. And for C, I have 4 plus 3 and 6 minus 1. And for point D, I have 4 plus 3 and 2 minus 1. So for A, I will get 2, 1. For B, I will have 2, 4. For C, I will have 7, 5. And for D, I will have 7, 1. Okay? All right. Let's see here. On example C, they give us a graph with our coordinates. So what we have to do is we actually have to find our coordinates first. So for S, our coordinates are negative 4, 3. For T, our coordinates are 6, 6. And for U, our coordinates are 4, negative 2. So what we're going to do for each set of points, for S prime, we will subtract 2 from negative 4. So we have negative 4 minus 2. And we will add 3 to 3. So we'll get negative 6, 6. For T, we have 6 minus 2 and 6 plus 3. So we'll get 4, 9. And for U prime, we have 4 minus 2 and negative 2 plus 3. So we'll get 2, 1 for those new points. All right, for D, the same thing. We got to figure out what our coordinates are. For J, we have negative 6, 5. For K, we have negative 3, 5. For L, we have negative 1, 2. And for M, we have negative 8, 2. So for J prime, we'll add 4 to their X, and we will subtract 3 from 5. So we'll get -2, +2. For k prime, we have -3 plus 4 and 5 minus 3. So we'll get 1, 2. For L prime, we have -1 plus 4 and 2 minus 3. So we'll get 3, -1. And for M prime, we have -8 plus 4 and 2 minus 3. So we'll have -4, -1 for those points. Okay, so on example 4, we have to write a rule for the translation of the figure. So what you want to do is you just want to pick a point and figure out how it's getting from one point to the other. So notice the prime, the points with the prime is the new figure. So this here, this one is our new figure. So we start here and this is where we're going to, okay? So if we pick a point, so let's just go with F. Okay, so if we're going from F, we're starting here and we're going to here. So basically we want to figure out how far right and how far down. So basically we just count the coordinates. So if we count, and basically all I'm doing is I'm counting 1, 2, 3, 4, 5, 6, 7. I went to the right 7, and since I'm moving right, that's a +7. And then I'm going down, so I'm going 1, 2, 3, 4, 5, 6, 7. I went down 7, so that's going to be a -7. So my rule for X and Y is I added 7 to X and I subtracted 7 from Y. We could also write it as a vector like we did in the earlier examples, like that, in those pointy brackets. Okay, so on this example, this shape is the prime, because you can tell with the little hash marks there. So we're going from this shape to this shape. Okay, we went from here to here. So if we go from F to G, this is where we're going. Okay. So remember, you do the X first. So we go in 1, 2, 3, 4. So that was left 4. A left is negative. Okay, so for our X, we would do -4, and we went down 1, 2, 3. So we went down 3, so Y -3. Okay, we could also write it as a vector. We would just put -4 and -3 if we were doing it as a vector. Okay, now we get to a composition. A composition is just more than one translation. You're just doing more than one thing. So if we graph RS with endpoints -8 and 5, so if we do -8 and 5, so here's point R, and S with -6 and 8. Okay. So here is RS, and it's image after the composition. Okay, so the first translation that we're going to do is we're going to add 5 and subtract 2. Okay, so the first thing we're going to do, if we do -8 plus 5, and let's see here. So this is for R, and then 5 minus 2. And then for S, we'll do -6 plus 5 and 8 minus 2. So that's going to give us -3, 3, and -1, 6. Okay, so we've got -3, 3, and -1, 6. Okay, that's our first translation. All right, then if we do another one, the next translation, we take -3, 3. Oops. And what we want to do is we want to take the negative 3 and subtract 4. And that 3 and subtract 2. And we want to take the negative 1 and subtract 4. And take the 6 and subtract 2 to get our new set of points. So we'll get negative 7, negative 1. And we'll get negative 5 and 4. So negative 7, negative 1. Sorry, that should be a positive 1. Let's see here. This should be a positive 1. So negative 7, 1. And that was our second rotation. So notice I put 2 little hash marks there. And then negative 5, 4. So that was a composition. That was just more than one translation.